Okay, so the nice thing about this PowerPoint, there's only 52 slides, so it shouldn't take us an incredible amount of time. So I'm just going to start, and we're going to go through the whole thing in one sitting. So here we're talking about 10.1 and 10.2. So this is an overview of both of these. 10.1, we're going to introduce linear correlation, independent, dependent variables, and the types of correlation. We're going to construct and interpret scatter plots and compute the correlation coefficient. So this is knowledge, and this is skill, and this is skill right here. And then 10.2, we're going to compute the equation of the regression line and be able to use the regression line to predict future values of the variable. And here we start 10.1, correlation, a relationship between two variables. The data can be represented by ordered pairs, x, y. X is the independent or explanatory variable, and y is the dependent or response variable. A scatter plot can be used to determine whether a linear straight line correlation exists between two variables. Now, straight line correlation is not the only type of correlation that we're going to talk about, but it is the most common, and it is the one that we really want, is a straight line correlation. Okay, so a scatter plot. Here we have some points, an x and y, 5 points of each, and so each one of these is an ordered pair. 1, -4, 2, -2, 3, -1, 4, 0, 5, 2. And each one of these is plotted. Now, it's not a perfectly straight line, but it is generally linear. And so we would say, yes, there appears to be a linear correlation between these points. Okay, so types of correlation. If our correlation has a negative slope, we would say this is generally a negative linear correlation. As x increases, y tends to decrease. This is a positive linear correlation. It's not perfect, but we're going to talk about the how we tell when it's a perfect line and not. As x increases, y tends to increase. That's a positive slope and a positive linear correlation. This one down here looks like it has no correlation at all. There's no way to figure out a line in that thing. And this one looks like it's an upside down parabola. So that is not linear. It looks like it may have a nonlinear, maybe a parabolic correlation, but in any case, it's definitely not linear. So now we're going to talk about how do we determine whether the scatter plot would have a positive slope, negative slope, or not follow a straight line pattern. So let's look at some examples. Determine whether the points in a scatter plot for the two variables are likely to have a positive slope, a negative slope, or not follow a straight line pattern. The number of hours you study for an exam and the score you make on that exam. Well, hopefully the more hours you study, the more likely you are to get a high grade. As your study time goes up, your grade on the exam will hopefully go up. So that's a positive correlation and a positive slope, a positive linear correlation. So we would expect positive. The price of a used car and the number of miles on the odometer. So we know that the price of a car goes down as the number of miles it's been driven goes up. So that would be a negative correlation, therefore a negative slope. The pressure on the gas pedal and the speed of the car. Again, as the pressure on the gas pedal goes up, the speed of the car goes up. So that would be a positive correlation. And shoe size and IQ. Well, since shoe size has no effect on IQ whatsoever, as far as we know, we should see no correlation for that one. I'm sorry about my screen. My computer is dying. Okay, so now they're giving you the answers, which I basically already went through with you. The scatter plot would have a positive slope for hours studied versus our score on an exam. number of miles on an odometer will negatively affect the price of the car. So the price will decrease. That will have a negative slope. The more you push on the gas pedal, the faster the car will go. Thus, the scatter plot would have a positive slope. And lastly, we would expect there is not a relationship, linear otherwise, between the IQ and his or her shoe size. So here's an example of constructing a scatter plot. An economist wants to determine whether there is a linear relationship between a country's gross domestic product and carbon dioxide CO2 emissions. The data are shown in the table. Display the data in a scatter plot and determine whether there appears to be a positive or negative linear correlation or no correlation. So here's our data. And here is the graph. So basically, these are just data points. $1.6 trillion and 428.2 CO2 emissions per millions of metric tons. So, or in millions of metric tons. So, this is the graph, and it looks like it has a positive, it's going up, not down. As the GDP increases, then the CO2 emissions are also increasing. So that would be a positive correlation. It appears to be a positive linear correlation. As the gross domestic products increase, the carbon dioxide emissions tend to increase. And here we have some data from Old Faithful. Old Faithful, located in Yellowstone National Park, is the world's most famous geyser. The duration in minutes of several of Old Faithful's eruptions and times in minutes until the next eruption are shown in the table. Using TI-83, TI-84, display the data in a scatter plot. Determine the type of correlation. So the first thing we're going to have to do is enter all of this data in the X column and all of this data in the Y column. So all of the X's will be in your L1 column and all of the Y's will be in your L2 column. So enter the X values into list L1 and the Y values into list L2 as shown here. And then we're going to use the stat plot to construct the scatter plot. So stat plot, so here I have my calculator, and this right here above this key is stat plot. So we have to do second stat plot. So second y equals gives us the stat plot on our calculator. So then once we get there, we're going to do second stat plot. Turn on the calculator helps. And then you're going to see plot 1. So I'm going to hit enter on plot 1. Can you see that screen? I think I got too much light here. Hit enter. And then you come up with this, which is what they have right here on this screen. It looks the same on my calculator. You want your plot 1 on. You want to put your cursor on the first picture under type because that's your scatter plot. Then you're going to come down here and choose your marking. I like the little box usually. And then when you graph the data points that you've already entered in your L1 and L2, you come up with your scatter plot. Now, what they did not put on here that you might need to do is adjust your window. Because notice your L1 is in seconds or minutes, but they're very small, and your L2 is, I think, the height that the water goes up. And so this one is higher, and so you're going to need a scale adjustment there. On your window button right here, you would want to go to window and adjust your scale. Okay, so notice what they did here. They've got 5 is how far they go on the X, but on the Y, they go from 50 to 100. So in order to get that, we would adjust our window here, 0 to 5 or 1 to 5, because that's what they seem to do. And then they would make their scale. They could make the scale 0.1, and then the Y minimum here is 50 and the Y max is 100. But I don't have the correct data in there, so it's not going to work anyway. Okay, so let's go to the next slide. From the scatter plot, it appears that the variables have a positive linear correlation. So now we're going to talk about the correlation coefficient. We have a number that tells us how close to a line the data is. The correlation coefficient is a measure of the strength and the direction of a linear relationship between two variables. The symbol R represents the sample correlation coefficient. And the formula is there. So R, the correlation coefficient, equals, and we're going to talk about how to get this now. The population correlation coefficient is represented by rho. Now, outside the scope of this course, you would deal with the rho in trying to determine whether it would be good to get a regression line or not, but that's outside the scope of what we're doing in our class. But you do need to know that rho is the population correlation and the population correlation coefficient, and R is the sample correlation coefficient. Okay, so this is what correlation coefficients do. They go from -1 to 0 to 1. There are no correlation coefficients less than -1 or greater than 1. It has a range of -1 to 1. This is a R of -1. It is a perfect slope, okay, a perfect negative correlation. The line is linear. There's no points off the line. R is close to 0. There is no linear correlation. We could not make a line going through there. It's just too scattered. And then if R is 1, there is a perfect positive correlation. In other words, the points lie exactly on a line. Now, here are the rules. We have scatter plots and correlation. If R is positive, that's the correlation coefficient is positive, then the scatter plot has a positive slope. And the variables are said to have a positive linear relationship. If R is negative, then the scatter plot has a negative slope and the variables are said to have a negative linear relationship. If R is 0, then no linear relationship exists between the two variables. If R is 1, then the data fall in a perfectly straight line with a positive slope. If R is -1, then the data fall in a perfectly straight line with a negative slope. If two variables have a strong positive or negative relationship, we say that the two variables are correlated. The strength of the correlation is expressed by the absolute value of R, or the absolute value of the correlation coefficient. The larger the absolute value of R is, the stronger the correlation. Okay, but again, the R is going to be at best 1, okay, because the range of the correlation coefficient goes between -1 and 1. But if we take the absolute value, the greatest that it could be is 1. So here are some pictures. So a strong negative correlation, it's not -1, but it is -0.91, which is very close to -1. So that is a strong negative correlation. Not a perfect line, but we can definitely see a linear slant. This is a strong positive. It's 0.88, which is positive. It's close to 1, but not perfect. This is a weak positive correlation. It's positive, so it's going generally up, but it's 0.42, which is not close to 1. So you've got a lot of points that are going far away from the correlation coefficient. And this one is nonlinear. They're showing you the, it definitely does not look like a line. It's going up and then it's coming down. This is 0.07, so it is not looking linear at all. So, how do we go about finding a correlation coefficient? We saw a bunch of correlation coefficients already calculated for us, but how do we calculate them? So, find the sum of the x values. So your sum of x is given to you in your one variable stats. Find the sum of the y values, multiply each x value by its corresponding y value, and then find the sum. So we're going to multiply x times y and sum those up. Square each x value and then sum them. Square each y value and then sum them. And then we're going to use those 5 things we just figured out to calculate the correlation. So n, which is the number of data points that we have, times the sum of xy minus the sum of all the x's times the sum of all the y's. Square root is on the bottom, and so there's the formula there. Fairly complicated. So here we have an example. Calculate the correlation coefficient for the gross domestic products and carbon dioxide emissions data. What can you conclude? So we've already seen this data in there once. We found the scatter plot of this data. So now here they've done a nice chart for us. So here's the x values, the y values, the x and the y multiplied together. So they're summing up each one of these columns. All of the x squared, so 1.6 squared is 2.56. They're summing up all of these. All the y squareds, they're summing up all of those. And then they summarized those 5 columns right here. And then they put down their formula. They plugged in 10 because there were 10 data points. Okay, and then the sum of the xy's was this one, so they put that one in there, minus the sum of all the x's times the sum of all the y's, so it's this one times this one. And then on the bottom they had 10, which was the n, the number of data points, and then the sum of the x squared was this one, so they put that there, minus the sum of the x's squared, so it was that one squared. And then they did the same thing, plugging in the values here, and they come up with 0.882. So R is 0.882 suggests a strong positive linear correlation. As the gross domestic product increases, the carbon dioxide emissions also increase. So 0.882, we saw a 0.882 right here. Let's see if we can get back to it. This was a 0.88. So this was a strong positive correlation, and that's what this data had also. Okay, so let's get to this one here. So now, as the gross domestic product increases, the carbon dioxide emissions also increase. So now we're going to do the same thing using our calculator. So we enter the data into our calculator by pressing Stat and Edit. We enter the values for the GDP in X, and we enter in L1, and we enter the values for the CO2 emissions, which is your Y. In L2, we press Stat Calculate, LinReg. And LinReg is the 4th option down, and we press Enter twice. Okay? And this is what we get. And notice what we get for our correlation, 0.882. Okay, so now this R squared, we're not going to worry about that one right now. But this is the form of your regression line. Y is AX plus B, where A, which is your slope, is 196.12, and your B, which is your y-intercept, is 102.2. So we can make a line, and you need to know this. This is your correlation coefficient. Now, isn't it cool that you didn't have to calculate that? It came up on your calculator, but it does equal what we came up with before. So now, this is important. This is a big ta-da moment. Final example in the class. So I'm going to start an example right now, which we are going to continue to do all 4 of the things that we have to do. Now, so far, you know how to find how to make a scatter plot and how to find a correlation coefficient. But now we're going to add how to find a regression line and how to use that regression line to make predictions. So this is your final example in the whole class, and I wanted to give you that little ta-da moment so that you would know how excited I am. I'm really excited. Okay, so constructing a scatter plot, a marketing manager conducted a study to determine whether there is a linear relationship between money spent on advertising and company sales. The data are shown in the table. Display the data in a scatter plot and determine whether there appears to be a positive or negative correlation or no linear correlation. So we have our data, and the data is entered into my calculator already. So to find that data, I'll show you in a minute here. So here we have the scatter plot just by getting our x-axis, our y-axis. Notice that they're using a broken graph here because we didn't start until 1.4, and our scale is what? 1.4, 1.6, 1.8, and we didn't have any data before that, so they made a little broken graph. Also, on the y-axis, our data started at 180, and that would be very tedious to have all this data shoved up because we're doing 20 steps in between, and so they make a little broken graph here to show that. So you need to be able to make a scatter plot. There appears to be a positive linear correlation. As the advertising expenses increase, the sales tend to increase also. Calculate the correlation coefficient for the advertising expenditures and the company sales. What can you conclude? Okay, so when we're looking at this, we've got the data points here, the X data points, the Y data points. Remember, summing the X, summing the Y, all of the X's and Y's multiplied together, and then we sum those at the bottom. The X squared, we take this one and we square it, and we add those up. And then lastly, the Y squareds. And then we plug those into our very nice, tedious formula. And there it is. And we get 0.9129, which we should check this with our technology. And we will actually see this again because we're going to continue this example. So 0.913, you should see that when we do this a little bit later. Okay, so now we're starting section 10.2. And we're talking about regression lines. So after verifying that the linear correlation between 2 variables is significant, which is something we are not doing in this course, that is something that's left for the next class. But when you go and do your homework, you're going to assume that there is a linear correlation between the 2 variables. And you're going to find the line of least squares, which is the regression line. So we're going to skip this step, and you're going to assume on all the problems in your homework that yes, there is a linear correlation. Okay, so then next we determine the equation of the line that best fits the data. So that's called the regression line, or the least squares line, or the line of best fit. It can be used to predict the value of y for a given value of x. So this is basically what we're going to do this whole second section. Make a regression line, use the regression line to predict a future value. And a residual is the difference between the observed y value and the predicted y value for a given x value on the line. So when they're talking about this least squares here, they're taking these little differences, these little residuals, and they wind up being squared, and we're looking for the residuals, the squares of the residuals, to be as small as possible. And so that's what's called a least squares regression. So for a given x value, observed y value minus the predicted y value is this little difference, which is your residual. Okay, so the observed y value where the y value is supposed to be, the observed y value where the y value is supposed to be, we take all of those differences. And when we're talking about a least squared line or a best fit line, the line for which the sum of the squares of the residuals is a minimum. Now the cool thing is your calculator is going to do that for you. The equation of a regression line for an independent variable x and a dependent variable y is this. So y is mx plus b, and notice the y hat is what we're going to call the regression line, where m is the slope, b is the y-intercept, nothing new there, predicted y value for the given x value, and here is how you could do it by hand using what you just found out for your correlation coefficient, the sum of the xy times the number of data values minus the sum of the x's times the sum of the y's divided by the data value number times the sum of the x squareds minus the sum of the x squared. So that is your m's. And then we've got our b, which is our y-intercept, which is our y bar minus our m x bar, which is this right here. Okay, so y bar is the mean of the y values in the data, and x bar is the mean of the x values in the data. So that would be easy to find, wouldn't it? Finding the mean of all the y's and finding the mean of all the x's, and your b is going to be this equation, which is right here. The regression line always passes through the point x bar, y bar, which is the mean of all the x's and the mean of all the y's as a point. So here we're going to find the equation of the regression line. And we are using the same example, the advertising expenses and the company sales, 225. Find the equation of the regression line for the advertising expenditures and the company sales data. So this is the same data we just used. To begin, we must determine which variable is the explanatory variable and which variable is the response variable. Way back in chapter 1, we talked about explanatory and response, and we want to use the advertising expenses to predict the company sales. Thus, advertising expenses, X, is the explanatory variable, which is your X variable, and sales, Y, is the response variable. So now, from 10.1, which was the last section, we had all of this data that we already had summed up for our correlation coefficient. There it is again. We didn't have to do anything new because we had already done it once. And then our M is our slope of our correlation line, and this is the equation for the M. And then our B is going to be our mean of our Y's minus M, which is there, times the mean of the X's. And there we go. Okay, so we wind up with the equation, which is MX plus B. Our M wound up being 50.72874, and our B wound up being 104.0607. Of course, that's a lot of math work, so aren't we glad that we can also do it on the calculator? So here is our regression line going through our data points. So we would do these data points the same way I already showed you, which is do your stat plot, go to your plot one, turn it on, choose your little symbol you're going to use, and then I'm going to show you how to put this line going through your data points here very shortly. So here is how we're going to do this using your TI 83, 84. In order to enter our points in, we're going to press Stat, select option 1, which is your edit. Enter the values for the advertising expenses, that's your X variable, put it in L1. The values for your company sales, which is your Y value, put it in L2. Press Stat, calculate, and choose your LNREG option, and press enter twice. So here I did some of these on the calculator for you. Here was entering all of the data values. So basically you're going to do your stat edit, and then you're going to enter your values in. Your X goes in L1, your Y goes in L2. Hopefully by now you know how to do that really, really well. And then we're going to do stat calc, and we're going to go all the way down to LNREG. I didn't show the LNREG there, but I should have. And then this is your LNREG, and what you get when you calculate it all out. Notice we've got the R, 0.9129, which was the same R we got before. Now, they rounded it to 0.913 when we calculated it out. And there it is on your calculator screen, 0.913. Now, if for some reason you have your calculator, you do your LNREG, and you don't get an R, it's happened to me before, just do a Google search on why my TI 83, TI 84 does not give me a correlation coefficient, and they will tell you how to fix that error. It's just something that you don't have turned on that you need to have turned on, and I've forgotten what it was, but you can do a real quick search. This is what it should look like. If yours does not look that way, you need to go make that little correction and make sure you have your calculator set up the way it needs to be. This is a little bit clearer view where I went through and did them for you. The R squared we're not going to mess with right now, but the R squared is something that you would do if you were going into 10.3 and 10.4, which is beyond the scope of this course. The big thing you need to know is that your R is your correlation coefficient. And now, to be able to plot the points, we're going to press second Y equals. Okay, so on your calculator, it's the second button and then the Y equals button. And when you do that, you're going to go here to this window, and you're going to turn on plot 1. Make sure your cursor's on plot 1, that it says on. That's the on right there that my cursor's on. The cursor should hover on type picture number 1, so that's where your picture should be, which is your scatter plot picture. Then go down to your mark and specify the desired symbol. I like to use the box symbol for mine. Adjust the window as needed. In other words, your window, which is right here, that key right there is your window key, and you may need to adjust. If you don't see your points, it may be because your scale on your window needs adjusting. Okay, so to graph the regression line, type Y equals and enter your regression line. So your Y equals line is right here. So you're going to type in that line, and you're going to enter your Y equals. Then you're going to hit the graph again, and you should see your regression line running through the middle of your data points. So here is my picture of me entering our equation into Y1 equals. Okay, so there's my screen, and then here is the regression line going through my data points. It will not go through your data points until you have entered it into the screen. So now the last skill is predicting Y values using our regression equation. So we just found this regression equation. We figured out how to plot it, all those cool things, but now we're going to use this equation to predict the expected company sales, which is our Y value, for the following advertising expenses, which is our X value. So here we're entering an X and we're coming out with a Y. Enter the X here and come out with the Y. So now, section 9.1, I think this was supposed to be 10.1 here. I think that's a miscopy because I forgot to change it to 10.1. So that's my bad. Okay, so here we have $1.5 thousand and $1.8 thousand and $2.5 thousand. So let's look at $1.5 thousand and we're going to plug that in, and 1.5, our equation was in thousands of dollars when we graphed it, so we're not going to put the thousand after it because our equation took thousands of dollars. So we plug in the 1.5, we come out with the y hat is equal to 180.155 when the advertising expenses are 1.5 thousand or 1,500. Then the company sales are about 180,155, because remember this was also in thousands. And then $1.8 thousand, we're going to enter the 1.8 and we're going to come out with this as our y value. And then $2.5 thousand, we put the 2.5 in our equation. Again, this was our slope, this was our x values. We substitute it in and we get out the company sales. Prediction values are meaningful only for x values in or close to the range of data. The x values in the original data set range from 1.4 to 2.6. So it would not be appropriate to use the regression line to predict company sales for advertising expenses such as 0.5 or 5.0. In other words, we need to stay in this range because we know something about this data range. We really don't know what happens before that data range or after that data range. So we're going to stick in or close to that range, and 0.5 is not close to 1.4. So it would not be appropriate to use our line to predict something way before or way after the range.
Okay, so to review, we have learned how to make a scatter plot. We have learned how to find a correlation coefficient. We have learned how to find a linear regression line, and we have learned how to use that line to predict values of the y variable. Those 4 skills are the only skills you are responsible for this section. Okay, so you remember that you are allowed to have a calculator on your final exam, and so I would use my calculator to find my correlation coefficient and my linreg line. I would not try to do it by hand unless I just had to. And I am not going to require you to do it by hand. However, I did want you to know that it can be found by hand, and the method that it takes to find it by hand is just plugging in all of those columns and finding some of the x's and the sum of the y's and the sum of the x squareds and the sum of the y squareds and the sum of the x's times the y's. And you find all of those and you follow the pattern and you put them in the formula and you calculate it out. And you get the same thing that you do when you use your linreg. So I would use your linreg. It's a lot faster. And we are done with all of our material for Chapter 10 and for the entire class. So remember, Chapter 10 does not have a quiz or a test. It has only one homework. And that one homework is going to be a bonus homework for you to boost your grade. Please do it. You need to know this material because you're going to have at least 3 problems from Chapter 10 on your final exam, and you need to know the material. But it's very simple, and you're allowed to use your calculator. Do not get frustrated with the homework. Just do the ones that I've specified. Those 4 skills is all you need to do. And remember to assume that finding a linear regression is allowed on all of the lines that I put on there. They will ask you, should you do a linear regression? Just answer yes every time, because I only gave you problems that you can do a linear regression on. Everything else is outside the scope of this class, and this is Mrs. A. May God bless your day.